Okay, so in this video, we will use the simplex method to maximize the objective function p equals x plus 2y plus 7z, subject to the constraints, the first one, second one, and here we have a third constraint, z being at most 4, and as always, all of the variables, in our case x, y, and z, must be non-negative. So the first step, as always, is to convert the inequalities back into equalities with the help of slack variables. If you look at the first inequality, there is something different than in the previous examples. There is a variable on the right hand side. Now we need to rewrite the inequality as all the multiples of the variables on the left hand side being at most the constant term. So here we'd get 3x. Now if you send 2y on the left hand side, it becomes negative 2y plus 3z, and this would be at most 30. So if we add just the right amount, s1, then we'll get that this is equal to 30. Let's do the same thing with the second inequality. Once again, there's an x on the right hand side. It needs to be put on the left hand side of the inequality. So it will become obviously a negative x. Then plus 4y plus 4z. And this would be at most 40. So if we add just the right amount, say s2, we'll get the equality with 40. And we have now a third inequality, z being at most 4. So here this is simply z. And if we add to z just the right quantity, we'll have an equality with 4. And now we need a third slack variable s3, and this will equal 4. That's the first step. So transforming each inequality into an equality with the help of the slack variables, remembering that we want all of the variables on the left hand side of our equality. Now we transform the objective function. As always, we leave p where it is and we send the variables onto the left hand side with the objective function, and so this will become negative x, negative 2y, negative 7z plus p is equal to 0. And now we're good to go. We can construct the initial simplex matrix. So we have our variables x, y, z, our three slack variables s1, s2, s3, with the objective function p. So first row, 3, negative 2, 3, 1, 0, 0, 0, 30. Second equation, negative 1, 4, 4, 0, 1, 0, 0, positive 40. Third equation, 0, 0, 1, 0, 0, 1, 0, 4. And the third and final equation, negative 1, negative 2, negative 7, 0, 0, 0, 1, 0. So now we have our initial simplex matrix. As always, we then single out the largest negative value in the bottom row, which here is negative 7. We look in the column above it. We take only the positive entries. Here, they're all positive. And we find for each entry the ratio that is the constant term over the corresponding entry. So here the ratio will be 4 divided by 1, which is 4. For this entry, the ratio is 40 divided by 4, which is positive 10. And for the entry here the ratio is 30 over 3, which also is positive 10. As always, we now single out the entry that yields the smallest ratio, here being 4, and so now we have to turn this entry into our first pivoting 1, but it already is. So now that we already have for free a pivoting 1, we will use it to kill the entries both above and below. So let's do this. Let's recopy the third row, as it is the only one that we're not going to change here. So 0, 0, pivoting 1, 0, 0, 1, 0, 4. Let's kill the 7 by doing row 4 plus 7 row 3. So negative 1 plus 7, negative 1, negative 2 plus 7, negative 2, negative 7 plus 7, 0, 0 plus 0, 0 plus 0, 0 plus 7, 7, 1 plus 0, 1, 0 plus 4 times 7, 28. Let's scale this 4 by doing row 2 minus 4 of row 3. So negative 1, 4 stay the same. 4 minus 4 is 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 4, negative 4. 0 minus 0, 0. 40 minus 4 times 4 is 40 minus 16, which gives us 24. And now let's perform the last operation. So row 1 minus 3, row 3. So 3 minus 0, 3. Negative 2 minus 0, negative 2. 3 minus 3, 0. 1 minus 0, 1. 0 minus 0, 0. 0 minus 3, negative 3. 0 minus 0, 0. And 30 minus 3 times 4, 30 minus 12, which gives us positive 18. And now this completes our first step in the simplex method. And now we ask again, are there any negative entries in the bottom row? The answer is yes, there are 2. Well, we choose the largest negative value, and now we look up in the above column, and we only consider positive entries. So we ignore the negative 2, and we ignore the 0, and so here by default, the entry 4 wins, right? Because by excluding 0 and the negative entry, we would then look at the ratio of the constant terms over the positive entries and pick the entry giving the smallest ratio. As there's a single entry that is positive, it will be the smallest ratio by default. Just for good measure, we can do it. 24 over 4 gives us 6. But as this is again the only ratio, this will now become our second pivoting 1. And to turn the 4 into a pivoting 1, we multiply row 2 by 1/4. So let's do so. Let's recopy first the rows that we're not changing. And I'll multiply row 2 by 1/4. So I have negative 1/4. Our second pivoting 1, 0, 0, 1/4, -1, 0, +6. Now that we have our second pivoting 1, we must kill the entries both above and below. Well, let's do so. We can recopy row 2 and row 3, as we're not going to change those two. And now let's kill the entries above and below. So let's do row 1 plus 2 row 2. So we'll have 3 plus 2 times -1/4 is 3 minus 1/2. But 3 is 6 over 2. 6 minus 1 is 5, and so we get 5 over 2. -2 plus 2 is 0. 0 plus 2, 0. 1 plus 0, 1. 0 plus 2 times 1/4 is 0 plus 1/2, 1/2. -3 plus 2 times -1 is -2, -5. 0 plus 0, 0. 18 plus 2 times 6 is plus 12, which gives us 30. Let me just double check quickly. Good. Let's kill now this entry by doing row 4 minus 2 of row 2. So -1 minus 2 times -1/4, so it's -1 plus 1/2, which is -1/2. Yeah, I picked the right entry, yeah. 2 minus 2, 0. 0 minus 0, 0. 0 minus 0, 0. 0 minus 2 times -1/4 is 0 minus 1/2, -1/2. 7 minus 2 times -1 is plus 2, 9. 1 minus 0, 1. 28 minus, oops. Aha, I made a mistake here. I've miscopied. If you look, from here to here, all I did was multiply row 2 by 1/4. And instead of recopying the -2 as a -2, I've recopied as a +2. Now, things will work out a little better. So instead of doing row 4 minus 2 row 2, we do row 4 plus 2 row 2. So let me just erase this, and we'll just recopy it, or redo it, I should say. So -1 plus 2 times -1/4, so -1 minus 1/2, -3/2. -2 plus 2, 0. 0 plus 0, 0. 0 plus 0, 0. 0 plus 2 times 1/4, 1/2. 7 plus 2 times -1, 7 minus 2, +5. 1 plus 0, 1. 28 plus 2 times 6 is 12. 28 plus 12 is 40. Now we're good to go. Okay. Sorry about that. When you have a large simplex matrix, it's easy to make a mistake by miscopying one of the entries, as there are so many entries. So once again, we are done now with the second step in the simplex method. we ask, are we done? So we consider the entries in the bottom row. If they were all non-negative, we would be done, but there's still a negative entry here. As it is the only one, it wins by default. And remember, we always take the largest negative entry, but again, there's only one, so we take this one. Now we look at the positive entries above. There is only one, so we must turn the 5/2 into our third pivoting one. As again, there's only going to be one positive ratio, as both of these are ignored. And we will get our third pivoting one by multiplying row 1 by 2/5. So let's do so. Okay. So let's multiply this row by 2/5. So we'll get our pivoting 1, 0, 0, 2/5. 2/5 times 1/2 is 1/5. 2/5 times -5 is -2. Times 0 is 0. 2/5 times 30, well 30/5 is 6, times 2 is 12. And now we can recopy the other three rows. So -1/4, 1, 0, 0, 1/4, -1, 0, 6, 0, 0, 1, 0, 0, 1, 0, 4, -3/2, 0, 0, 0, 1/2, 5, 1, and 40. Alright, so we're good to go. Now that we have our third pivoting 1, we want to kill the entries below. So we will do row 2 plus 1/4 row 1, and row 4 plus 3/2 row 1. Let us first recopy the rows that we're not changing. So row 1 will stay the same. Row 3 stays the same. And now let's apply our operation. So row 2 plus 1/4 of row 1. So -1/4 plus 1/4, 0. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1/4 times 2/5. Well, 0 plus 1/4 times 2/5. 2/2 is 1/2. 1/2 times 1/5 is 1/10. 1/4 plus 1/4 times 1/5 multiply by 5 here, you'll get 5/20. So you get 5 plus 1, 6 over 20, common factor of 2, which gives you 3/10. -1 plus 1/4 times -2 is -1/2, minus 1, -3/2. 0 plus 1/4 times 0 is 0 plus 0 is 0. 6 plus 1/4 times 12. Quarter times 12 is 3, plus 6 is 9. Alright, so one operation done. Let's now kill the negative 3 over 2. So we now do row 4 plus 3 half of row 1. So 0, 0 plus 3 half of 0 is 0. 0 plus 3 half of 0 is 0. 0 plus 3 half of 2 over 5. Well, the 2's will cancel, and we're going to get 3 over 5. 1 half plus 3 half of 1/5. Now let me check. Yeah, so 1 half plus 3 over 2 times 1/5, so 3 over 10. Put this over 10, so it's 5 over 5, so it gives us 8 over 10. Common factor of 2, 4 over 5. 5 plus 3 half times negative 2. Well, 3 half times negative 2 is negative 3. 5 minus 3 is positive 2. 1 plus 3 half times 0 is 1 plus 0, 1. And 40 plus 3 half times 12. Well, 12 over 2 is 6 times 3 is 18. 18 plus 40 is 58. This completes our third step in the simplex method, and if you now look at the bottom row, all of the entries are non-negative, which means that we have attained our largest possible value for the objective function p. Let's write our conclusion from our final simplex matrix. Recall that the variables were x, y, z. The slack variables were s1, s2, s3, with the objective function p. As always, we set the non-basic variables to 0. So here, s1 is non-basic, s2 is non-basic, and s3 is non-basic. So we set s1 to equal s2 to equal s3 to equal 0. If those are equal to 0, then we can ignore these columns, as we would get again for each row plus the coefficient times 0, which is 0, so they become irrelevant. And now we can solve for our basic variables using the corresponding pivoting ones. Well, let's solve for x. X equals 12. Let's solve for y. Y equals 9. Let's solve for z. Z equals 4. And with these three values, the objective function attains its maximum value of 58. And we're done. So we maximize p when x is 12, y is 9, z is 4, and the maximum value of p at this point is 58. Once again, we can do a quick check to see that this is consistent with the original objective function p. Well, if you recall, the function was x plus 2y plus 7z. If you replace x by 12, 12 plus 2 times y, 2 times 9, 18, plus 7 times z, which is 4, plus 28. Well, 12 plus 18 is 30. 30 plus 28 is 58. So it does work out. And that's it. And you can see that in our solution, I made a slight mistake in miscopying a negative 2 for a positive 2. So always be really careful when you have a large simplex matrix, when you're recopying, that you're being very careful with the entries.